Okay, welcome to part 2 of the DMMT tutorial. In this case, we're going to be changing model inputs and assumptions and seeing the effects that they have. So the first thing that it asks us to do is to look at the Assume Historical Marsh Loss Rates Continue box down in the Model Inputs. So in the Model Inputs tab, you can scroll down to the bottom, and you have this box suggesting this is an important model assumption. It does have significant effects on model results, but you can assume that historic marsh loss rates continue and that they're actually additive to sea level rise losses. There's a little bit of information to the right here if you would like to read more about that. So we're going to click that box, and then we're going to go to the top of the Model Inputs tab, and we're going to select Calculate for the first time. And that asks us to identify the run with a text string. So I'll call this historic loss. I will select OK, and the model will start to run. Now it takes a little bit of time to run because what it's doing is it's going through data that has been extracted for each one of these sites, SLAM data. It's going through each one of the uncertainty analysis runs that were extracted from each of these sites. And then it is running that through utility functions and coming up with expected value utilities for all this. So there's a lot of calculations that are going on in the background, but I will pause. And the run is now completed. You get a little box telling you what has been completed and where the model results are updated. So you select OK on that. And the question that is asked is, if you assume these historical marsh loss rates, which site provides the highest flood vulnerability reduction or wave attenuation? That's perhaps a better term for that. So we go to, let's look at the ecosystem service benefits. And you can see that results are a little bit different in terms of the expected value. You have a lot more marsh loss that is predicted, and the utilities fall down a little bit more heavily. Another interesting point here is that Udall's Cove used to have quite a bit of flood vulnerability reduction because it's one of the highest marsh loss areas. It now does not have a whole lot of benefits with regards to that, but Idlewild actually now has the highest flood vulnerability reduction or wave attenuation. The second question is, based on this run, for which sites can combined adaptation strategies potentially mitigate sea level rise losses? So to answer this question, we move over to the Adaptation Strategy Benefits tab, and we look at the current utility versus 21 utility with additive adaptation strategies. Now, if you'll recall last time, the adaptation strategies always exceeded the current condition for all sites. Now for this site, this only occurs for Alley's Creek, Pelham Bay Cove, and maybe Udall's Cove is not quite making up for it, but it's close. So it's a different set of assumptions that we're working with here. The next question is, what happens to marsh fate at Udall's Cove? So if I go to do this, I have to go back to the Ecosystem Service Benefits tab, click there, and take a look at Udall's Cove. Now this is under a restoration scenario. We have a lot of loss. If we go to the strategy and select no migration, should be even a little bit worse. Not as much marsh up front, and then almost all of that's being lost. If you do look at a migration strategy, that's even with this high marsh loss, there's enough marsh migration to transgression to uplands that Udall's Cove would predicted to have about the same expected value for marshlands as it did at the beginning of the simulation. Okay, moving on to question B. It suggests that we are wanting to look at specifically at utilities in the future from 2050 to 2100, when accelerated sea level rise is expected to be at its worst. So in order to look at that time frame, we can go into the model inputs and change the beginning year to 2050 and then recalculate. I will identify this run as 2050 to 2100 and then select OK and let it run. And now that the run is complete, it gives me the message. And we can take a look at the next question. The question is, what strategy will provide the greatest incremental benefit, and which one gives the greatest benefit per cost? So to start, I'm going to look at the model outputs tab, and you can see we have a lot of older runs in there as well. So what I'm actually do is clear the older results by clicking on this button, and then I'm going to sort by the incremental benefit. And so it looks as though Alley's Creek in Queens has the highest incremental benefit in terms of potential for marsh migration. In terms of looking at benefit per cost, we need to go over to the Adaptation Strategy Benefits tab. And in this case, it's very hard to compete with the very inexpensive, large quantity of public land at Pelham Bay and W.T. Davis sites. But once you get past those high sets of benefits, restoring marsh in 1974 is very competitive in many of these cases here, in many of these sites, especially Udall's Cove. I will note that this current versus future utility graph is currently sort of hardwired to 2016, so it doesn't really work when you change the time period. So the next question suggests that we go back to the original 2016 time period. I'll go back to model inputs, set this back to 2016. And then it suggests that costs should be edited. What if we have updated cost information? How would we do that? And the scenario that's put in place here is that restoration in 1974 is too high by a factor of 2 for various reasons. And so what I'm going to do is I'm going to replace these with half the cost. The easiest way to do that is for me to type 0.5 in one box and then paste special, multiply, and values over onto that. And that will give me half the cost that we had previously. It also suggested that W.T. Davis, that the purchase and restoration costs will be double. So to do that, I'm going to do a very similar process. I'm going to type 2 into a box, copy it, and paste special as values. Oops. I'll try that again. Paste special, multiply as values. So no matter how you did that manually or otherwise, your costs should have ended up looking like this. W.T. Davis at 2165 and 2720, and the total marsh restoration costs being at 33.2 million. Now let's go back up and rerun it. I'm going to go back. And I'm going to call this cost adjustment. Hit OK. So now that the run has completed, we can take a look at the results. And we'll go over to the adaptation strategy benefits. And one of the keys here is that when we're keeping track of multiple runs, you have to go up to the run identification and select which run you want to look at in this particular tab. So we want to look at the cost adjustment run. And as usual, Pelham Bay Cove and because of the low cost of land, is most competitive. However, for other sites, restoring to 1974 becomes the best choice, with the exception of W.T. Davis, in which case the marsh restoration isn't as effective. The last thing that we want to do is go to the model inputs and just take a look at the discount rate factor here. So the question is, what happens if you value current marsh more than future marsh just due to uncertainty in sea level rise, uncertainty due to political conditions, whatever other case there may be. Bird in hand is worth 2 in the bush. So there's a discount rate input here, and you can change this from 1% to 2%. Or any kind of discount factor you want. This is what you can do. The discount factor inputs are right over here to the left. So if you want to use a 1% discount factor, then you would copy these inputs, and then you would paste those under the discount factors onto the left. And then we can see that as of 2100, the marsh utility is only going to be valued at about 43% of what is at the current time. That might have an impact on the results. So if we go ahead and I don't know why that got hidden. If we go ahead and calculate, we'll call this discount rate. Select OK. Now the model runs are complete. We can take a look at the results. If you look at the ecosystem service benefits, you can see that things fall even further because you're discounting this, so it has about half the value that it would have had in 2106. And let's take a look and see what impact that has. Select the run identification of the discount rate, and you can comparatively look at that. It looks like the marsh restoration is even more competitive. The restored in 1974 is even more competitive than it was before in terms of the relative benefits that you get from that versus other sites. That's an interesting result, and I think that's because you're restoring the marsh up front, so you're getting the current benefits from it now. I mean, I guess the question is, in 50 years, maybe you could do another marsh restoration, and so that's a reason to discount and to value this higher than it would be otherwise. The last thing that I want to point out on this is that in our survey results, we had many survey users just leave all site-specific results essentially flat. So, for example, looking at things like dry land recreation, they said we don't really know the sites well enough, so we're leaving them all flat. But you can definitely use, so these could probably use a little bit more. There's some more differences. For example, we could use the SAVI index to calculate where the underserved communities are. In some cases, it makes sense to leave them flat if you don't know the site-specific differences, such as nutrient sequestration. But for some elements like recreation or flood vulnerability, I mean, if you have a site which is really not protecting any infrastructure, then wave attenuation is going to be less important. So I think that there's still some work that can be done to refine these case studies. Anyway, I hope that you find this to be a useful tool. Please don't hesitate to ask us any questions, and hopefully this short tutorial helps you find your way around it.